Sam Fearn from the University of Durham. Can we steal the mic back, please? Who will be talking about Stack.
Okay, so I'm talking this morning about Stack. Those of you that know anything about Stack, Stack is not a tool for producing HTML lecture notes. So this is going to be a slightly different kind of talk to the three that have come before. So I'm going to give a quick overview about what Stack actually is before kind of talking about how you might use this with some of the other things we've been talking about this morning and start embedding Stack materials inside some HTML lecture notes. So Stack is a system for generating questions that you can give to your students for them to use for assessment. So these are going to be potentially randomized questions using some random variables, and then generate specific feedback to students' attempts on those questions, where the feedback can take into account not only the random variables that you've used to run the question, so it's specific to the version of the question that the student's seeing, but also what the student has done while attempting to answer that question. And it's built on a computer algebra system. Specifically, it's using something called Maxima as the computer algebra system that kind of sits under this, so that you can have a reliable way of doing things like testing whether things are algebraically equivalent using some kind of robust computer algebra system. And typically, that would be used as a Moodle plugin, and that's the point I'm coming back to. And so what's good about Stack? Well, feedback can be generated for these kind of questions instantly. So rather than giving your students some kind of homework sheet and then taking at least a week, maybe two, depending on your class size, to give them some feedback, which they're then going to ignore because your course has moved on by 2 weeks and they're worried about what you're doing now. So they never read that feedback. It was all a total waste of time. Instead, you can give them some feedback instantly. It perhaps won't always be as detailed as a human might have written in person, but the fact that you give it them immediately means they can actually use that while they're still thinking about that material and actually potentially benefit from it. So they can immediately take action on that feedback. And since you're writing potentially randomized questions, you can give the student some feedback on the question they've just tried and then let them try a new version of a question that's been re-randomized. They can test whether they've actually understood the feedback that you've given them, whether they can now put this into practice to be able to do better on a similar kind of question when they try it again. So they get an immediate chance to understand whether they've actually been able to understand the feedback and improve from that. And we're not just testing whether the answer that a student gives you is some specific thing, either a specific number, a specific expression, or even whether it's necessarily just algebraically equivalent to some specific thing. Instead, we can kind of interrogate a student's answer and test features about that answer. For instance, if they're giving me a vector as the answer to a question, I can see whether it's the right dimension. I can see whether it's got a particular length I'm interested in, as opposed to just, is it the right vector that I'm looking for? And that lets me do all sorts of things. It lets me give students partial credit the same way I would if I was marking by hand, because I can potentially tell that they have done some things correctly, even if their answer is not the or a correct answer. That means if I've got a question with multiple parts, I can take into account the student's answer to one part of the question and use that to take into account how I'm marking the second part of the question. And in particular, I can write questions that don't just have a unique answer, because I can check whether the answer a student has given me satisfies whatever conditions I'm interested in. So this is why I might use something like Stack. So let me just briefly say how we use this in Durham, or at least the scale at which we're using this in Durham. So we've been using this since about 2019, where we started testing it in a couple of first-year modules, in our calculus and linear algebra modules. We're now using it across basically every single first-year module we run, almost every second-year module we run, some of our third-year modules. I don't think any of our fourth-year modules are yet using it, but I suspect that's simply a matter of time. This, I think, is the more interesting number. I think I calculated this the last time I gave a similar talk to this. I estimate that about 25,000 scripts per year go through Stack, which otherwise, before we started using Stack, were being graded by hand, by PhD students and by lecturers. So that's a significant amount of work that we're now doing through this kind of automated system rather than marking by hand. And we are mostly interested in doing this for formative purposes, by which I mean we're using this as a chance for students to check their understanding and to learn by trying to do mathematics, as opposed to simply giving them a grade, giving them a number that we write down in a database and that contributes towards their mark at the end of the year. Because of that, our typical usage pattern is that students can try questions as many times as they like, keep re-randomizing until they feel they're satisfied that they've understood what they want and they're ready to move on. And typically students are very positive about this, particularly when you balance this with other types of formative assessment. Okay, I don't want to talk too much about this because I don't have very long. Oh, there's about 10 members of staff in our department. Our department's just over 100, I think about 110 members of staff. So about a tenth of the department is involved in writing questions in some respect. I'd say there's a core team of about 5 or 6 people who do things like also run training workshops, support other members of staff, and so on. Okay, so let me show you briefly what Stack actually looks like. I'm focusing mostly on what this looks like to the student. So here's a quick demo. Maybe this needs to be bigger. Okay, so this is a question that just asked me to do some calculation. This probably would not be in a university course, but it asked me to calculate some integral. So let me put in some answer. Let me say this is, let me get this deliberately wrong. Promise I am doing it wrong deliberately. So let me get x minus 6 to the 7th. Okay, so I can mark this answer and I get some feedback given on my answer. It checks, in this case, it differentiates the answer I've given and sees whether it's the same as the expression I've started with. So it's not just comparing it to something it knows is correct, but is actually testing whether it solves the question I've asked the student to do. Is it an antiderivative, basically? And gives me some feedback. So it tells me I've got it wrong, and I can have another try at this question. So I was doing x minus 6 to the 6. If I try this again, I get the same question, fine. I was expecting that to give me a different one. Was that just chance, or have I not got this randomized? Yeah, there we go. Okay, so that was just coincidence. So these are random questions. Okay, it doesn't look like there's an awful lot of randomization in this question, but in principle, I can do a new version of this question and see whether I've really understood what I got wrong the previous time. Okay, I just want to show you a couple of examples of the kinds of things that I can do with this. I can do things that also plot lines, plot pictures based on the random things I'm setting up. So here I'm expected to put in the equation of a line that's parallel to this. And the feedback can involve things like drawing the answer the student gives alongside the original line that was in the question, and therefore pointing out the fact that the answer I've given here has an intersection with the line that I was given, and therefore these things can't be parallel, and I can really see what's going on. This is maybe the kind of feedback you'd give if a student did this on paper. There are some fun kind of interactive questions I might do with this. This is a question that asks me to think about the epsilon delta definition of continuity by, for a given value of epsilon, what's the question here? It asks me to find a delta such that for some point, so for some given value of epsilon, it asks me kind of what is the largest delta I can use such that all points within delta of the given x value I'm using are sufficiently close. Okay, this is the epsilon delta definition, but it allows me to actually explore that and start writing questions in a way that students can really engage with and actually start understanding what can be a technical definition. Here's one I particularly like. This asks me to find a function which smoothly joins these two line segments, a cubic function which smoothly joins these two line segments. So let me put in some answer. Again, this is the incorrect answer. So if I put in an incorrect answer here, I get a picture of the incorrect answer I put in over the interval that I was looking at, and it can tell me what my answer does satisfy and what it doesn't satisfy. So here it tells me it would have some extra lines that appeared if it didn't join these two lines. So I don't see those. I have given the equation of a cubic which joins the two line segments, but I haven't done so smoothly, and it's able to check that they're not smooth, right? That I don't get the derivatives I was expecting at those endpoints. So I can really, as a student, start understanding why this answer is not the correct answer. Okay. And I don't want to talk about this one. I don't want to talk about this one. let me just show you a couple more advanced kind of things that I can do before I can talk about how I do this in HTML. So here are some questions that a colleague put in their complex analysis course this year. These ask me to, these give me some region of some rays in the complex plane, some region of the complex plane, and ask me whether this is a star-like domain. I don't do complex analysis, but I seem to remember this means, can I find a point that connects to every other point in the complex plane? So this is a nice graphical question that asks me to put a point into this picture. Can I put a point in this picture that will now connect to everything else in the complex plane, where the domain, where the region I'm trying to see if it's star-like is the complex plane minus the red lines, okay? So I put this example in just to show you that I can do these kind of graphical things where you might write a question on paper that asks a student to draw a picture to answer this. There are ways of doing clever kind of things like this in systems like Stack 2. Another one that I like that he wrote involves me taking some function that I'm expected to integrate and plotting both some integration contour as well as some points where the function has poles, and using that to then go on and answer a question about how to do some contour integral of this function, which formula I can use from the course notes apply to this kind of integration question, okay, and so on. So I put these in just to show you that you can do some more advanced things. Okay, let me move on to the next thing I wanted to say. So Stack is great. I love Stack. I love using Stack for putting assessment questions in my courses. And typically we do this through Moodle. That means that we can use Stack for assessments which are formal as well as formative. So I can get grading data from this. I can export it into whatever database we're using in the department. I've got a lot of control about how students engage with these questions, whether they're allowed to retry questions, when they're allowed to try questions. I can apply rules that say certain students have extensions, all the kind of things that you would expect to be able to do for the kind of assessments that you might want to run. And if I have an assessment which has some kind of summative component, these are probably all things I need. But I probably don't need all of these if I just want students to be able to try doing some maths and see if they understand. Okay, Moodle is then a bit of an overkill. And let me show you what this looks like in our courses. So we're a Blackboard institution in Durham, and we're using Stack as a Moodle plugin. So here's the calculus course that I've been teaching for the last couple of years. I've got a nice kind of folder for my assignments. If I go into my assignments, I get a link over to our Stack server, our Moodle server, that we run a separate Moodle server in the department to run Stack with. So students have to navigate over to the Moodle server, find the assessment that they've been asked to do for the week. Okay, so they come down, they find some assessment. Then they realize that they probably need to look at their course notes to be able to do this. So they go back to Blackboard and they go and find the section in Blackboard where I've got my course notes. And then they go and find the right week and they open up the right section of the course notes. Laura, I was glad you did ODEs because I'm doing the same thing. It's first order ODEs. So now they go and find these course notes and now they read the course notes and they try and solve the question. Okay, fine. That's kind of a bit of a faff. There's a lot to navigate between those two parts to actually go and try a question. I've got to find the question that I want to try, as well as finding the course notes. If I'm just reading the course notes, it's not immediately going to be obvious to me whether there's a question I can use to practice this or not. And so something that I think is really powerful is everyone this morning has talked about the accessibility benefits of using HTML lecture notes. I just want to mention that this also gives you the possibility of kind of interactivity that is not possible with things like PDF. So we can embed Stack questions directly inside our lecture notes. I just want to demo that very quickly. So here I have some text file. If I print the text file, that's not what I want to do. If I run the text file, I get some PDF. Okay, so this is what this little snippet of LaTeX looks like as a set of course notes. It's a little section, just like Laura did, of first order separable ODEs. Okay, fine. Now what I want to do, I'm going to do this morning with Pandoc. David mentioned that Pandoc is the engine that sits underneath Quarto. So really everything I'm saying is kind of agnostic to what tool you use to convert your material to HTML. I'm using kind of raw Pandoc this morning just for simplicity. At least it's the thing I'm most familiar with doing. So all I'm going to do is I'm going to tell my computer to convert this set of LaTeX notes into a markdown file. Okay, so now I have some markdown file. This is kind of the fairly human readable markdown that I might want to be typing if I was going to use something like Quarto. And of course, I can convert that markdown straight to HTML. So let's just have a quick look at what that looks like. Okay, I've got far fewer bells and whistles the way I'm doing it than Quarto is kind of helping me put in. I'm not claiming this is quite as accessible off the bat as Quarto might be. I certainly don't have some of the easy ways of changing font sizes and colors and things, but it's not what I'm focusing on this morning. So here's my HTML lecture notes, exactly the same as the PDF. Now I see that in my lecture notes, I have some examples about first order separable ODEs. And one of the questions I had in Moodle for Stack was some first order separable ODEs. So let's put one into my lecture notes. And what I'm going to do is I'm going to take my lecture notes. I'm going to find the place that I want to insert an example into my lecture notes. I wrote this down earlier, so I can just copy and paste it. I'm going to put a line in that says I want to put a stack question in here. The stack question is the question whose name is first order ODE separable explicit. And I'm going to put something at the top of the file, at the top of the markdown file, that tells it where it should expect to find that question. So this is a file on my computer that I've exported from Moodle that's got my, my stack questions in. I'm just going to reproduce the HTML. And now to do this, I need to run it off a proper web server rather than just my computer. So you can ignore the specifics of what's happening here. I'm just copying it over to a little web server that's running. So this is now running here. So now I have the same lecture notes as before, but I suddenly have something that says I can try an example question. I can click this button, and it goes and grabs me a random question, exactly the same way Moodle is doing. It goes and puts this into the lecture notes. I can try this question. I'm not going to try and do this while you're watching. Okay, and I get some feedback on my answer exactly as if I was doing this in Moodle. So I get all the benefits of a student about seeing whether I understand what's going on here, but without the faff of actually needing to go and find a formal assessment living in my Moodle server. Before I get kicked off the stage, let me just maybe show you some kind of extra fun things that you might do with this same idea. I want to do, I'm nearly out of time, so I'm going to do two things at once. I'm going to copy some other interactive element in here and another stack question, which I think was supposed to go here in my notes. Now this uses an additional question file. So I'm going to tell it I've got two question files that I'm trying to load questions from now. Let's build this. Let's copy it back to my web server. Okay, so now we get extra interactive elements. I've got the solution to the ODE plotted in here as a Desmos example. I think someone else is talking about Desmos later, so let me not focus on that. But I've also got another type of question in here, which I think is where this is even more powerful. So in class, I typically tell them why this formula for separable ODEs actually solves a separable ODE, right? I show them if you differentiate both sides, you really get something which solves the ODE. Well, now this is embedded as a proof question in Stack. I get the ability to construct a proof to this question by kind of dragging and dropping some blocks around until I get something that looks like a proof to this question. I'm not going to scroll down a little bit further because I broke this while writing it on the train this morning. And so this example doesn't perfectly work. The question works in Moodle. I can't work out exactly what's broken in the last half an hour. So this is not working as a live example, but in principle, I now build up a proof to this question, see whether I've got the proof of this kind of statement right as well. So I can start replacing proofs in my courses with interactive things that let students check whether they've understood a proof by working with these kind of proof-based questions and seeing whether they understand them. Okay, I'm probably about out of time. Let me stop.